Hey guys, good morning. We are going to go through the first part of 3.5. You can see we're talking about equations of parallel and perpendicular lines. Wanted to break this up over 2 days just to not to overwhelm anything. So we're going to just take a little bit of time to look at some things dealing with slope and how it relates to parallel and perpendicular lines. Now, first of all, assignment-wise, we are going to have a big ideas. Okay, so just be aware of that. Okay, it's the first part of it. It's only 6 questions. It's a pretty simple and straightforward here today. So again, we're talking parallel and perpendicular lines. Okay, the first one, in a coordinate plane, two distinct non-vertical lines are parallel if and only if they have the same slope. Okay, so we've talked about parallel lines. I know we've been really emphasizing right here that they both have the same arrows. Well, now we're looking at it in terms of a coordinate plane. So this means that they both have the same slope. Now on this one, you can see that they're decreasing, so maybe they both are -3/4 or something like that. Or maybe it's just -2, whatever it may be. They both are going to have the exact same slope, which means that they are never going to cross. Okay? Now the other thing that we're going to start to see, if you see any two vertical lines, so we're talking about obviously lines that look like this, those will be our vertical lines, and then the horizontal lines, something like that, those would be parallel as well. Okay? Now, just a reminder, anytime we're talking about a vertical line like this, we're talking about x is equal to some number, and anytime it's a horizontal line, it's going to be y is equal to some number. So if you ever see x equals or y equals, what you're looking for parallel is going to be the exact same thing. Now, the flip side of that are perpendicular. Now, again, I know that we've been talking right here. We want to see that box for it to be perpendicular. Now, what does that mean in the coordinate plane? Well, if we're going to have two lines that are perpendicular, their product is going to be -1. Okay? Now, what does that mean for us? Well, if you think about that blue line, you can see that's decreasing, right? Let's say that that has that -3/4, right? Now, here's what we want. Really, two things need to happen. Number one, we would flip that fraction, make that 4/3, and then we would flip that sign. Since that's -3, we would want this to be a positive 4/3. So those two would be what we call perpendicular because we flip the sign and we flip the number. Now, here's one that's going to be maybe a little bit more unique, but say it's just a +2 for the slope. Well, if we flip that, we would make that 1/2, and if we flip the sign, it'd be from positive to negative. Okay, so perpendicular, they're going to be opposite reciprocal slope. So big takeaway from this page should be if we're looking at parallel lines, that means that we're going to be dealing with two slopes that are going to be the exact same. Whether they're both -3/4, whether they're both -2, they're both going to be the exact same. If they're perpendicular, they're going to be opposite reciprocals, meaning that they're going to have the same numbers. They're just going to be flipped fractions, and they're going to be opposite signs. Now, if we're talking about those horizontal and vertical, if we're talking about one of each, then those would be perpendicular. Okay, and again, if we're talking about y equals, it's going to be a horizontal line like that. And then if we're talking about x equals, it'd be something like that. Okay, so if you see anything in that way where, again, this would be our y equals, and then this would be our x equals, those would be perpendicular. Okay? So what we're going to look to do are look at a couple different graphs to see if we can figure out, number one, what the slopes are going to be, and then number two, are they related to one another? Now, something I want to make sure we remember, okay, is the slope formula. So the slope formula is y2 minus y1 over x2 minus x1. Now what we want to go through and do is find the slope for all four of those lines. Okay, and then we want to compare which ones are parallel, which ones are perpendicular. Okay, so I'm going to start with line A. Now line A, you can see, has the points -3, 2, and then 0, 3. All right, now as I'm doing this, I'm going to go ahead, just like we've done in the past, I'm going to call this x1, y1, and this x2, y2. So that way I know exactly what it needs to be plugged in where. So if I look at my slope formula, y2 minus y1, so 3 minus 2, over x2, which is 0, minus -3. Now 3 minus 2 up top is 1. 0 minus -3 is going to become +3, and it's going to be 1/3 for my slope. Now that's line A. We want to now do the same thing with line B. Okay, so it looks like for line B, my points are going to be there in the red. So I've got the point 2, 0, and then 0, -1. Now, as we're going through this, you could flip the order of those, but I'm going to go with the ones I see first. So now I'm talking, there's x1, y1, There's x2, y2. So let's find that slope. And I know I put m up there, but m is just the expression or the variable that's used for slope. So y2 minus y1, so negative 1 minus 0 over 0 minus 2. Now, negative 1 minus 0, that's going to be negative 1. 0 minus 2 is going to be negative 2. Now, something we want to check on this. Anytime we see that it's a negative or a negative, we're going to go ahead and make that positive. So really, 1/2 is going to be a better answer on that. Okay. All right, so we got those two. All right, so now we're going to try line C. And line C is there in the green. Looks like I got negative 1, negative 5. And then I've got 1, negative 4. And so now, again, let's go ahead. There's my x1, y1. There's x2, y2. So let's see here. I've got now y2, which is negative 4, minus y1, which is negative 5, all over x2, which is 1, minus negative 1. All right, so negative 4 minus negative 1. Again, anytime it's minus and negative, we're going to be looking at plus positive, so that's going to be 1. And then 1 minus negative 1, that's going to become a positive 2. Okay, so we can see that those two are the same, which is great. But let's wait just a second. We'll come back and figure out what line D is as well. Okay, so I got line D is there in my purple, so that's going to be negative 2, 0. And then it looks like it also shares the point negative 3, 2. Okay, I know that's a little bit harder to see, but they do have that point of overlap right there. All right, so let's tag that there. So there's x1, y1, x2, y2. Okay, so now I've got, let's see here, it's going to be 2 minus 0 over negative 3 minus negative 2. Okay. Now 2 minus 0 is going to give me 2. Negative 3 minus negative 2 plus positive is going to be negative 1. So really this is the same thing as negative 2. Okay. All right, so first thing that we needed to do, we've done. We've gone through, we found all 4 slopes. Okay, so on a problem like this, we want to find the slopes. And again, we're looking to use that right there, that our slope formula. So y2 minus y1 over x2 minus x1. Now, let's see. First of all, we want to check to see if anything's parallel. Well, if we look, do we have any slopes that are the exact same? And we do. We've got 1/2 and 1/2. Those two are both the exact same. So we can go ahead and say B, we'll still use our symbol for parallel. It's parallel to C. Okay. Now we check 1/3. Do we have another 1/3 in there? No. Do we have another negative 2 in there? No. So it looks like B is in parallel to C is the only pair of parallel lines that we have. Okay, now perpendicular. Remember, perpendicular means the opposite reciprocal, so we're going to flip it. So let's check the 1/3. If I would flip that, that would give me 3 over 1, and it'd be negative 3. Do I see negative 3 in there? No, so there's really nothing parallel, or I'm sorry, perpendicular to A. What about for B? If I flip that, it's going to be 2 over 1, and it's negative. Well, I got negative 2 there. I got negative 2 there. Well, what does that mean for us? Well, that means that B would be perpendicular to D. Now, since C is got the same slope, we can say C is perpendicular to D as well. Okay, so those are our 3 answers. Okay, so on this type of problem, what we want to look to do, again, we need to find the slope of all the lines and then look to compare. Now, for your assignment, you're going to have 2 examples like this where you're going to go through and try to find the slopes of all 4 lines and compare. You're also going to have just some where you have 2 lines, okay, or 2 sets of points where you don't have the line. We're going to make sure we use this slope formula here to figure it out. And again, it's y2 minus y1 over x2 minus x1.